There, bring you now to your regularly scheduled program.
Mr. Newfeld?
Yeah. Yeah, I like it if you get your units more, so I know what I'm looking at when I look at it quickly. But yeah, you're on the right track.
Yeah. Wait, that's correct. You want a page?
I want to be, and you have, that is a method interpreter.
Okay.
It's not the only method, but it's
correct.
Yep.
Okay.
I think so. I'll double check the answer.
Basically, what this is so confusing is it's not that in an island of drinking water. You don't find what is left
You
over.
are, in a way.
They're both not like converting. They both
No,
work
yes.
easily. Really?
Yeah. You
This
don't
is
remember
left
rules of
over
it, right?
excess.
Okay,
Your
what
excess
do you
is
know
is the
about
pH.
NaOH and ACL in terms of when they react? What type of arrow do they have?
Yeah. And I find when you're strong,
They're
right?
both dilated. It's a strong base and strong acid. One more.
So if they're both strong, take the greater of the
They're
two.
both strong.
minus
Well,
it.
if either one's strong, it's actually tricky.
Oh, okay.
So it's like double.
Oh.
Okay.
And we don't run it.
Just write one line, because it's the next point,
Yeah.
which is anything on the right going to affect the pH? No. So the only question is, which one are you going to have left over?
pH.
Well, no, I'm fine, you are diluting it, and so converting it to moles is a method of doing it as well, that may be very helpful.
Converting it back to moles per liter.
Figure out which one you're gonna have left over, and,
Okay, so whatever.
and what are you doing? Are you locking, who's
No,
that locking?
I didn't do that
Who's the
one.
one with the glasses?
It's Mr. Rector.
You're not wearing glasses. I don't like the chin on that one. I'm a little
Eric
disturbed.
drew it, so.
Your mark's going down. Why is my hair so thin?
Oh my god.
I was over there with Taylor. How could I be drawing?
Eric, don't know. 2.5.
Quit lying, Eric.
Eric is innocent. He's innocent.
So you're staying back to do extra courses, right? You're not planning university courses?
Oh, I'm innocent.
The more people
I'll
seem
take
to
the
be
ball.
sitting down, I'll let, you're on,
Now we can go. For
Oh, what did you do?
2.5.
So you want point two, why did you do point two?
I don't know.
Where's that from?
Wes.
Anyway.
This is so wrong.
Oh my god. No,
Those numbers from?
Use the negative y.
Eric.
Yeah.
You're multiplying the together, the difference. What?
And now I'm seeing it.
Let's give it a try.
You got 0.05 there instead of 1.15.
Maybe lose it by 2.
That one, is that one supposed to be that one?
Law.
Oh, 50 minutes. Oh, that's one. So, yes, you're getting that concentration for what?
That's the final concentration.
Of, excellent, do that. But you also have any other way.
What is that? Is that a rat?
I don't know.
Oh,
It might be. By how much?
Just like
The
pull
number.
that grass, basically.
No, I did it over here. I know.
Oh, really?
She gives me the good one.
And you need your units and you need to label it, otherwise it's just a bunch of numbers to me, I don't know what it is. I gotta communicate that.
No.
Okay, tell me what you did. There's two ways to do it, so, what was your way?
So yeah, this isn't you, Ben.
You did that one, right?
We divide out.
He did that one.
That one?
Me and you next.
Okay, what did you start off calculating?
The new concentration.
Of?
The concentration of the acid H.
Okay, so we got concentration of HCl. Okay, let's see if your phone up.
Yeah.
Put it away.
Yes, sir.
What is that, how did you calculate that?
Think it with the, what's it called?
Yeah, what, no, I need numbers and units.
Oh.
What's going on?
We just found that. We did the original molarity of HCl.
Okay, so that's
0.2.
0.200 molar, yeah.
And then you multiply that by the old volume over the new volume. Or, yeah, 50 over 100.
And what did that equal?
0.1. And then you take the
Excellent.
negative log of that.
Oh God, why?
Because that's when you go to the pH.
And then what did you do?
Then you're finished.
Well, but that's not the pH.
Wait, Mr. Nicole, I think we got.
Yeah, because there's a reaction happening. What does acids and bases do when they react? When they get together?
What in?
And give on hydrogen and give on hydrogen.
11.2.
Great chemistry. Acid plus base makes a,
Salt.
and
And the water.
Yeah. We just
that
talked
reaction
about-
has to happen before you calculate pH.
Right, yeah.
We got pH.
So this is a good number. You might need that number, but you need both numbers.
I need water.
What's the other numbers?
Starting with dry. Because they react. You need both.
Okay, well then, you did that too. That's
Good,
0.075.
So how did you calculate that? You got the
The same
0.150 molar,
thing times the same thing.
50 over 100 milliliters. And what did that equal?
0.075.
0.075. And then what did you do with those two numbers?
Why, maybe we multiply them and then take the negative log? I'm just guessing right now.
Yeah.
You add them? Oh, you subtract them.
I feel like you're just randomly guessing mathematical operations now.
James, what do we do with those two?
I want to know why you do any of those, even if one of those is right. So you have HCl plus NaOH goes to one-way arrow, H2O, and NaCl. Okay, if I can get everybody's attention for this one, Luca, I noticed more chaos and some really good approaches. Calculating moles right away will work and leaving it in moles. Calculating concentration right away with the new concentration will work. But where you have to adapt is, this is a standard grade 10 acid base. Acid plus base makes a salt plus water. So an acid and a base react each other and they completely annihilate each other. The only thing left are salt and water. There's nothing in here that'll affect the pH. So anything that's in here that got reacted isn't affecting the pH. So we need to know how much is left over. So this turns out, now in a couple of groups, they calculated the new concentration. That works. If you calculated the number of moles and just went 0.2 times 0.05, and that would also work. You can do the exact same thing. You just have to turn it into concentration at the end. So either approach would work. But if you have 0.100 molars of this, moles per liter, and you have 0.075 moles per liter of NaOH, which one are you going to have left over?
HCl.
HCl. How much?
0.001 or 0.025.
0.025. So HCl is in excess. And because they're in a 1-to-1 ratio, you don't really need to make up a table or anything. You can just say, oh, 0.075 of that is going to react with 0.075 of that. It's going to make that. So the only thing left over is 0.100 molar minus 0.075, because we know it's going to react, and we get the 0.025 molar. And then after that, the pH is just the negative log of that. This is the only grade 12 part, because we learned a new formula. But all of this would be like an easy stoichiometry from last year. But I do find that they need practice, because once you've done grade 12, it's a bit like when you do calculus and you go back to doing algebra, and all of a sudden your brain goes, I know how to do calculus, I don't know how to do algebra anymore. All the old stuff still applies. So reactions that have one-way arrows still annihilate each other. There's no equilibrium. You just can minus one from the other, and you can get an excess reagent. What was that for anybody that got it? 0.
Whoa.
No.
Oh, no.
2.602.
What?
I've got, I like the confidence and like,
Hold on. I'm checking it right now.
1.6.
1.602.
0.2.
Oh, we were off.
1.602, yeah.
Okay,
Never get it.
but
He's my quant.
does everybody see why we minus it?
Yes.
Luca?
Nope, nobody.
Okay. Because I did have a moment in which you're like, what do you do now? And they're like, minus it, divide it, maybe multiply it, maybe add it, maybe take it to the square root. The mathematical reaction you're doing is the minusing, but it's more important to know why. If these are annihilating each other, Luca?
Yes.
If these are annihilating each other, if this is using up 0.075 moles per liter, then how much of that will it be used up?
You repeat the question.
If this is 0.075 moles per liter, all of it's going to get used up. How much of the HCl will it use up?
I don't know, none.
No,
It's in a 1-to-1 ratio.
it'll use up.
Stoichiometry. All of it. But how, if you have 0.075, 0.075. So that's how much of this is going to be gone. So that's used up,
What's left?
and that's going to be, the total. So you're just figuring out what's left. So that's why it's a minus. If you had different numbers, if this turned out to be, 0.250, then you'd minus the other way. Then this one would be all used up and that wouldn't be. So there is still limiting reagent calculations. They're not going to be hard. They're going to be fairly easy ones like this. But they could have a 2-to-1 ratio if you have like a H2SO4 and an NaOH. And so you'll need to be able to do that a little bit. There are some practice problems like this in Hebden. Really do those. They help, especially as we get into titrations. Luca, is that okay?
Yeah.
Anybody else still confused as to why we minus? Now, if you did this in which you calculated the moles, you would have had very similar numbers. They just would have been smaller. You'd have minused them, and then you would have just had to turn it into a concentration by dividing it by 0.1 liter, I think. I think that's what you did.
Yeah, we mixed up two numbers. We got the wrong thing.
Oh, okay.
We did the
But if
process.
you're doing the process right, then that's fine.
We just like mixed up
Okay.
two numbers.
Now, we're now officially done PLO-L. Over the last few days, looking at the time we have there, this is my forming plan. Normally, I would say you test this week, JKL. Currently, what I'm going to say is you're going to have a quiz next week.
Wait. We have JK today, right?
Yeah, but quiz next week, JKL,
Oh, okay.
okay? Not a test, quiz. If you want a test, because you're like, I want this to count as a test, I know this stuff, I've been doing a lot of extra work and I want to improve my grade and I want it to count as a test, tell me and I'll put one into the testing center for you. You can write a test.
What test?
If you do
And it'll be on JKL only.
Oh,
If you do it
Right?
bad,
but it'll just be longer.
Well, the next test is going to be JKL MNO. So yes, can be replaced by a future test. But it will count as a test until that time. Okay?
It doesn't matter.
The reason is that rather than giving up a day to a test day, I'd rather have another learning day because right now, you are all here. At some point, some of you are going to leave and do sport things, in my experience. I hate that. If you all agree to go and join yoga, we won't have to do
What if we just play non-competitive? Isn't that the same thing?
this. No, because you still
If
go
we
away and
join
do it.
yoga, we
ODP
have to
goes
take
away.
it.
How about like non-competitive tennis? Like,
That'd be pretty good.
Because it's not like the tempting thing you think it is.
Are
It's
you
like,
a yoga
if you take yoga, you have to take a test. Don't take yoga.
they don't.
No, if you take yoga and nobody's ever gone, we have so much more time. We would actually be done the course like a week earlier. Because when people are gone, this is me teacher complaining now, so you can tune me out if you want. But when people are gone, my teaching actually gets slower because people ask more questions in the next
If
class.
we
We take
limited
longer to do the
the
material.
amount of time you complain about sports, then how much sooner will we finish?
5 minutes.
Okay.
Just 5 minutes.
Okay.
Yes.
No.
Now,
Yeah.
is there anybody who is deeply disturbed by this and they want like They're like, no, I want an in-class test only.
Nick is.
Okay. This way, it gets an extra day of teaching, which would be valuable right now. You're probably still going to have to make, because we're still going to be doing stuff later. Redox is coming. But this means I can start KA and KB. Pardon? Oh, you're doing it Monday and Tuesday.
We already got it.
We added them
You already
all.
handed them out.
I added them all up.
Mr. Phelps, how many more units do we have?
M&O, PQR, STUVW.
Wait,
What?
But STUVW is all done as like one unit. It's all redox.
Brad, you gave me 2.
Commission 12, then let's call it up.
I already have one.
Yeah. Did you not get one? Oh, okay. Also, I heard you complained about the pencils that are up there. And I have on order, and it just came in today, an electric pencil sharpener, which I swear means that when you sharpen the pencils, they will not come out all broken. Yeah. For you, man.
Why did you buy an electric pencil sharpener instead of just butter pencils?
Because when I looked it up, those pencils cost 4 times more than the other ones, and they are labeled the best pencil. So apparently, it's not the pencils.
So what you want, so instead of you bought a pencil sharpener, just get stapler.
Well, the person I was talking to said that the reason they come out broken is because we use mechanical ones. They go all over. The store person.
Oh,
Like here, Ms. Miller, or no, Ms. Miller. Okay, you got your things? Stop drawing, NA. I'm gonna start moving in your distraction class. Stop. Look at
yeah.
focus. Dylan, pick up your phone, put it up there. And what are you doing? We are starting today KA and KB finally. We're going to write KA and KB equilibrium expressions. Just as a reminder, we have products over reactants, that is KQ, that hasn't changed. So what I would like you to do is write the reaction for the acetic acid in water and write the KA expression for it. So write out the chemical equation and then write out the KA. That's what it is you gotta look at. Got a table, you got data tables.
What is acetic acid in water?
Yes, yes, that is the thing you have to know. I will ask someone at random in a moment what acetic acid is.
Acid is what is this?
Yeah, it's on the page.
Wait, pass me that seal.
Pardon? Where's yours?
Oh yeah, CH2C.
Oh, I saw.
Acetic acid.
Okay. Look, I thought I heard you say it. Did you?
CH3COO8.
Excellent. Now, what would its state be? Aqueous. And it's an what are we going to react it with?
Water.
What will its state be?
Liquid.
There we go.
Can't have aqueous water.
Shut up.
Is water wet? No.
It is.
What kind of arrows?
Or is wet water?
Double.
Double.
Water makes you water.
Cannot that which wets others also wet itself?
Indeed.
Oh.
I've wet myself.
Wait. Wait.
I'm gonna move on. What are the products?
CH3COO with a negative charge, and H3O with a positive charge.
You don't know what we're doing.
Both or
Yeah, I think
aqueous.
Oh, liquids.
And they write the names.
Excellent. So if we were to write a Ka for that,
1 point.
but someone, I'm going to press a button. It is called upon a name.
Uh-oh. It's over. He's cooked.
Products over reactants. You know, Kate, you do this.
Let it cook. Let it cook.
Hey, bro.
Go.
He's cooked.
No, you know.
Products of reactants.
Products over reactants. You can do this. You've done this. Tons. What are the products?
CH3COO.
CH3, COO minus. So we go that. And what would you multiply? Pardon? Times. So times H3O plus. So change that sign into a times.
Is it over CH3COH or
Yeah.
we include water?
No water.
Would we include water?
No.
No. Water is a liquid, so it is not included. So if you wrote this equation without water, and you just made this H plus, and you just like dissociated it, you get the same equation. Okay? And so that's how you write a Ka equation. That's it.
Okay.
Okay. If you write a Ka equation for a strong acid, you get infinity because the there's zero for the reactant, and so that's why they don't really have Kas and they're just strong. I will start. This is a bit early to start the quiz, but I know it's somebody's birthday today, so that way the class has a chance of getting lunch a little early if we start now. So put everything away, and I'm not telling you. I'm not telling you. Put everything away. I'll give you a data table. Get out your calculator and pencil.